Hello and welcome to Talking Points. I'm Dave Kelly, Director of Advanced Media Production at Cal State Long Beach. Today we'll be talking about sharks and robots and the recovery of marine ecosystems along California's coastline. My guest today is Dr. Chris Lowe. Dr. Lowe is a professor of marine biology. Welcome, Chris, and thank you for joining us on Talking Points.
Thanks for having me.
Let's start the conversation by sharing some good news with our viewers, because many of our viewers may not realize that there is some good news to talk about in terms of our marine environment. Tell us about that, if you would.
Well, I think we have some evidence to show that things are getting better. And after all the effort that we've put in to regulate and clean up the environment, I think we're seeing signs that that's happening. And the canary that I use is a white shark. That's our canary for this coal mine. And in this particular case, we're seeing what we think is ecosystem recovery because our big predators are coming back.
And you do spend a lot of time studying sharks. We'll get back to that in just a moment. But first, I want to talk about why the ecosystem is improving. And one of the reasons is because the water quality itself, the ocean water along the coast, has improved significantly over the last 40 years. And I think we can point to a watershed event, and I mean that literally and figuratively in this case, was the Clean Water Act of 1970. Tell us about that.
Well, you got to remember, along coastal California, our populations have been increasing exponentially. And it was really the 40s, 50s, and 60s that we saw some of the greatest development along our coastline. At that time, all these people living along the coastline were going to the bathroom every day, and that was getting discharged straight offshore. Raw sewage is literally being dumped off our coastline. And we saw some of our worst water quality in the 60s and 70s. And that was really what drove the Clean Water Act at a national level. So as a result of this massive increase in human population along our coastline, that water pollution that was not just coming from residents, but also industry that was growing in California, became a major problem. We had very polluted coastline. We had a lot of contaminants going into the water, pollutants going into the water, and we were beginning to see dramatic effects on the marine communities. So that was a catalyst that really spurred the Clean Water Act in Washington. Since then, California populations continue to rise, yet we have some of the best water quality that you can find anywhere in the world. Almost all of our wastewater treatment now is secondary and in some cases tertiary treatment. So we're putting out water that's actually cleaner than what we're taking in from the environment, which is very impressive with a growing human population. So animal communities are greatly affected by water quality. The amount of sunlight that penetrates there is going to dictate how much plankton can grow, and that's the basis of the food web. So cleaning up the water is one of the key factors that has enabled marine communities and predators to come back.
Which is the second point I wanted to make. In addition to the quality of the water improving significantly, also some of the predator populations and some of the species that we thought might be endangered actually are starting to come back.
Yeah, we had a lot of animal populations that were dramatically affected, not just by pollution, but by overfishing, hunting, things like that. Probably the best examples are marine mammals. At the late 1800s, early 1900s, marine mammal populations were hunted to virtual extinction. I mean, there were many populations that it was thought they would not be able to recover from that kind of pressure. And the Marine Mammal Protection Act was passed in 1973. And since 1973, we've seen most of our marine mammal populations in continental US increase. And now to the point where some people are a little worried that they've actually overpopulated. Probably one of the best examples that I can give is the California sea lion population. In 1920, biologists estimated that there were as few as 2,000 California sea lions in all of California and Baja. They had been literally hunted to the point where biologists thought they were going to go extinct. And then, of course, fishermen, if they saw them, they would just shoot them. They looked at them as competitors. They ate the same things we were fishing for. So anytime a fisherman saw a sea lion, they'd just kill him. Since the 70s, sea lion populations have been steadily increasing. But the most marked thing was in the 90s, mid-90s, when the Magnuson-Stevens Act was passed. That really required fisheries to clean up their acts. They could no longer kill marine mammals as bycatch. It wasn't intentional, it was bycatch. But since then, California sea lion populations have skyrocketed. It is now estimated that there are 470,000 California sea lions in California and Baja now. A population that was thought to absolutely be on its way to extinction has completely recovered. Some people even project that there are more sea lions now than there were prior to human hunting.
That's amazing. It shows that species can come back as long as there's something left to work with. Let's talk about gill netting. We've passed some legislation in California and have some very tight regulations about gill netting. Explain for our viewers what gill netting actually is and why has the banning of gill netting helped bring back the fish population?
Well, you know, the history of commercial fishing in California is a prominent one. In fact, Southern California was largely based on commercial fishing. We've saw a loss of most of that community. But probably the most marked commercial fishery that grew and developed in California was the gillnet fishery, which started in about the mid-70s, and it exploded with the advent of monofilament. So imagine a net that's made out of this clear plastic that when you put in the water turns invisible. The idea is the fish swim into the net and they get caught around their gills, hence the name gill net, and they are stuck in the net, they can't back out. This became a really effective and rapidly growing fishery in Southern California in particular. And there were thousands of boats that had permits to commercially gill net fish, and you could do it out of a fairly small vessel. So that fleet grew from the late 70s through the mid-90s, largely uncontrolled, and it became a very lucrative thing to do in California. But as a result of declining catch of the target species like white sea bass and California halibut, things that people like to eat, and in addition, huge bycasts of marine mammals and birds, that fishery became heavily regulated. So in coastal California, it became so bad that it was a state referendum, and the taxpayers actually get to vote on this. And it was banned, gill netting inshore in state waters out to 3 nautical miles was banned in 1994.
And as a result, we've seen the fish population come back.
So once you ban the use of that gill net fishery, that fishery was greatly reduced. Gill netting still exists. There are fishers that are still doing it, and it is a popular form of fishing. And since then, we've seen many of the species that were being affected by that fishery come back. So California sea lions is a great example. Birds, pelicans were being caught in that fishery. A bunch of coastal sharks, leopard sharks, soupfin sharks, angel sharks. All those populations have been coming back. Black sea bass, which are almost on the verge of extinction in the 50s, have come back since then. So there are many of these populations of coastal species that were caught as bycatch in that fishery that are showing great signs of recovery since the banning just in 1994.
Let's talk about sharks. You've spent a great deal of your research focused on sharks, and I know that your mentor, Dr. Don Nelson, was a pioneer in this effort, and you've carried on with his legacy. First, tell us a little bit about Don Nelson and what his contribution was to the area of shark research.
Well, Don was a pioneer. He was worldwide, recognized expert in shark behavior, and that was something that was unique. So I was really excited to have the opportunity to train with Don, get my master's degree working in Don's lab, and I learned a lot about some of the tools that Don had helped pioneer. So as his interest in studying shark behavior, you had very few choices back in those days. You could try to dive with them, which Don loved to do, but it gave you a really limited view of what sharks actually do, because you couldn't stay underwater long enough, or you couldn't see them at night, and they move great distances. So Don started using a technology called acoustic telemetry as a kind of a spy technology to spy on sharks and see where they go. And at the time, he actually had to make his own transmitters. So we used that technology, we cut the teeth on that technology, so to speak, at Cal State Long Beach. It was one of the first labs to use this. And it was exciting to be part of that.
And we're talking now about tagging sharks. And we have a video clip where you're actually using underwater robots to try to identify where sharks are that have been tagged. Tell us a little bit about this clip before we roll it.
So we're really interested in what a lot of these coastal sharks do. And believe it or not, even though they're so abundant and so common, we just haven't had the tools to properly study them. And now what's happened over the last 20 years is the technology's gotten better and better. In fact, we now have autonomous tools that we can use to go out and follow these sharks. And they can do it better than we can and more stealthily than we can. So we're really excited about using this new technology to do something we have never been able to do before.
Okay, let's take a look at this video clip with Chris and his team out looking for sharks using robots.
When I first started tracking sharks, the way we would do it is we'd put a transmitter on a shark and we'd have to follow it around from a boat. and then hopefully have time to take a quick sensor that we could measure the water temperature at different depths. But we couldn't do that and track the shark at the same time. And in addition, we didn't have GPS and a lot of this technology when I first started tracking sharks. So at the time, it was just follow an animal and see where it went. And that was great, but now we have so many other questions that we really want to answer, and all the technology is now finally available. The robots are going to enable us to pull all that together. What used to take a team of biologists in a ship, we can do with 2 robots and a group of students in a small boat. The robots are going to change the way we study sharks because they're going to enable us to do more things at once. They're going to enable us to not only characterize the water that the shark is moving through and what the sea floor is like, but we're going to be able to put that together with the animal's behavior. And we've never been able to do that before. My dream is to have a fleet of these robots that are out scouring the coast, listening for tagged fish and sharks, and measuring the water column and then beaming all that back to the lab. Future marine biology graduate students are going to be computer experts as well as marine biologists. And that's the direction we need to move.
Chris, you told us in that clip that future marine biologists will also be computer engineers or computer scientists. Where is this research going in the future?
Well, I think what's going to happen is this technology is getting cheaper, it's getting smaller, and it's getting in the hands of even community colleges. So the great thing about this technology is not only is it commercially available, but people are building their own. So it's kind of changing the way that people have had access to the technology. First of all, it's getting cheaper. Some of the robots that my colleagues use are $500,000 to $1 million a piece. That falls well outside the realm that us typical marine biologists would use. So these robots, because they're getting cheaper and cheaper and we're able to modify them in ways that enable them to do what we want them to do, is going to change how we study these animals because they can do things that a team of biologists can't do, and they can do it cheaper.
So what kinds of information will we learn from this robot technology down the line?
Well, the nice thing about the technology is we can couple all sorts of sensors on the robots. We can use the robots as basically ocean monitors, mobile ocean monitors. But not only are they monitoring the ocean, but they can be monitoring animals. We can mount video cameras on them in something called image sonar, which basically gives you a sound video image of what's going on around them. So we can then begin to use computer programs to stitch all this together and recreate a 3D environment around the animal we're following.
That's pretty exciting. Chris, we're going to take a break right now, but when we come back, we'll talk about what Chris's research is doing in terms of his conclusions about the coastal environment here in Southern California, and we'll also talk about how television documentaries are influencing public opinion about shark research. Stay with us. There's a world of opportunity available through the College of Continuing and Professional Education at Cal State Long Beach. Would you like to move ahead in the field of human resources and personnel management? Sign up for the Human Resources Management Certificate Program. You'll learn how to expand your knowledge and skills and advance in this dynamic industry. For more information, contact the College of Continuing and Professional Education at Cal State Long Beach. Welcome back to Talking Points. I'm Dave Kelly at Cal State Long Beach. My guest today is Dr. Chris Lowe. We're talking about sharks, research into shark populations, and also the recovery of marine ecosystems in California. Chris, before the break, we looked at that video clip. Excellent footage, by the way. And we did notice a lot of leopard sharks in that footage. Tell us about the leopard sharks. They're not the ones that are very scary.
No. So we use leopard sharks because they're very abundant. They're a coastal shark, and they're the ones that people are most likely to see along our coastline. They're a very, very docile shark. They feed on worms and clams and things like that. And their numbers are increasing basically because of better fisheries management. So we use them because they're a great model. They become a really good model species for us to develop some of our new technology on. And we've learned a lot about their behavior and movements already, so we know what we should expect to see when we apply this new technology.
But one of the areas that you're most focused on is white sharks, the predator sharks.
Right.
Those are the ones that movies and stories are built around.
Right.
Tell us about the white shark research. What is your white shark research telling you?
So one of the things that we've noticed, and this comes back to this story about ecosystem recovery, is that if marine mammal populations are coming back and fish populations are coming back because of better water quality and better fisheries management, these are the things that white sharks feed on. So the reason why we think we're seeing white shark populations come back is because their food base is returned, both for the juveniles, which eat primarily fish and that are found along our coastline in many of the same places that leopard sharks are found. But also the adults, which feed on marine mammals. And the marine mammal populations have come back gangbusters. So it kind of makes sense that we should expect to see white shark populations recover. But this has taken decades. This has literally taken decades for us to see these sorts of effects. So it's encouraging to see not just protection of white sharks has resulted in their recovery, but basically recovery of the ecosystem itself.
When we talk about white sharks and tagging the sharks and then trying to track their movements, we're talking about a very large range. What is the typical range of a white shark?
Well, that varies depending on their life stage. So for example, we've done a lot of tagging of baby white sharks along our coastline. And Southern California is the nursery for white sharks. So it's not uncommon to find, a 5-foot shark right along our beaches just outside the break anytime during the summer and fall months. We've managed to catch those sharks and put transmitters on them, different types, acoustic and satellite transmitters, and track their movements. So one of the things we've found is that during the summer months, they spend most of their time just swimming along our beaches, probably looking for easy things to catch, like stingrays. But in the winter, when our water temperatures start to drop, most of these sharks migrate south to Baja, and they tend to spend their entire winter there. Now, about 25% of the sharks we've tagged so far, we've actually documented coming back to Southern California in their subsequent summers. In fact, we've even had some of the sharks that have come back go in and spend time in LA Harbor. So this is a good indication that Southern California bite isn't just a place where they're born and they spend their first summer here because they don't know any better, but they come back probably because conditions are good.
When you mentioned a term, Southern California bite, what does that actually mean?
So the Southern California bite is actually a bite out of the coastline that extends from Santa Barbara down into northern Baja. So marine biologists and oceanographers refer to this whole area from San Diego to Santa Barbara as the Southern California bite. It's unique in that the water temperatures get warmer here, even though we have a cold California current coming down from Humboldt and Alaska carrying down cold water. So as a result, Southern California bite is considered one of the most productive habitats on the West Coast.
And just a little shark humor here. When we say bite, we don't mean B-I-T-E, we mean B-I-G-H-T.
That's correct.
That's how they define that. But anyway, talking about sharks and talking about television and stories and so on, we know that there's a very popular week on Discovery Channel known as Shark Week. And you've actually been a participant in some of those documentaries. Tell us about that process and some of your thoughts and concerns about how shark research is portrayed today on television.
Well, the media has helped generate this persona of sharks, and people have gobbled it up, no pun intended. But in many ways, it's created a hype that's hard to overcome. So one of the jobs that we're having is worldwide, many shark populations are being overfished. They're being killed for their fins. There are places where there are very few regulations on shark harvesting, and as a result, we're seeing dramatic declines in shark populations worldwide. It becomes hard to convince people to try to protect these animals if they're afraid of them. Unfortunately, Shark Week attempts to try to educate the public, but quite often in the background you can hear the dun-dun, music, which makes it hard to convince people that these animals are worthy of protection when we're still instilling that fear in the public. So I think they do a good job at getting information out to the public about sharks, but they also do a disservice in terms of providing this underlying fear that people actually crave.
Well, it's all about ratings, and of course fear generates ratings, and so I think they do try to present some of that research that you're talking about, but ultimately they want those ratings.
And I get that. As a scientist and educator, my job is to get good information out to the public. They become a great mechanism for us to do that, but it always comes at a cost. And the cost is that music playing in the background while you're giving a conservation message. So it becomes hard to do that. Now, with that said, we are seeing a change. We are seeing people's attitudes about sharks change. And that's been happening probably over the last 10 years. We'd like to see it happen faster because some shark populations are in pretty bad shape, and something needs to be done quicker than at a 10-year, 20-year scale. So hopefully the public, who are the consumers of Shark Week, will start demanding better programming.
In terms of an increase in the predator sharks, white sharks in Southern California and along the West Coast, what are some things that may happen in the future in terms of shark sightings if those populations come back?
Well, we're already seeing this. We're already seeing people sighting more sharks along the coastline. And in fact, during the summer, it's almost daily news. It's almost part of the daily news cycle. So as populations continue to go up, we expect this to keep happening. Now, there's a flip side to this, in that some people view this as being a bad thing. In other words, the more sharks you're going to see, it's not going to take long before somebody gets bitten. And that probably will happen. It has been happening, but not at a rate as you'd expect, considering the number of people that go in the water every single day in Southern California. So we suspect that in most cases, sharks avoid heavily populated beaches, which is a good sign. These babies, which are the ones that are being seen the most, really pose very little threat to humans. They're out there just outside the break. They're feeding on fishes on the bottom, stingrays, things like that. But they really don't pose much of a threat to humans. So the tough part's going to be convincing people that with these rising numbers, that they are going to see more sharks. And believe it or not, that's a good thing. We've actually spent a lot of money and a lot of political power and will to bring this about. So people should be excited if they see a shark.
You work with lifeguards. What do you tell the lifeguards?
Well, you know, what we want to do is give them the information that they can best educate the public with. And one of the things that we think is important is that people be aware of ocean dangers. They be aware of ocean risks and be ocean smart when they go in the water. So it's not just sharks, it's stingrays, it's riptides, it's pollution. There are a lot of things that people need to be aware of. And they need to do their homework. If you're going to go to a beach and you're going to use a water activity, know about what animals occur at those places. And the lifeguards are going to become a conduit for that information. So our job at the Shark Lab is to provide them with good information about what we know about sharks now, and give people the ammunition and information they need to be safe when they go in the water and to evaluate those risks themselves. Now, the reality of it is your chances of being bitten by a shark are so infinitesimally low that it really isn't worth worrying about. Far more people are killed driving to the beach in Southern California than would ever from encountering a shark. So the fact that people worry about this is a little disconcerting, but with better public education, we think we can change those attitudes.
And part of that public educational process involves letting people know that we as humans are not ocean mammals. We are land-based folks, and the marine environment belongs to the marine animals.
And that's another message, right? The message is we're visitors to the ocean. While we like to believe that we own and dominate all these places, the ocean is not Disneyland. There are no guarantees. So people really have to be ocean smart. They have to remember that they're a guest in that environment. We're not naturally made for that environment. A lot of people love to spend time there, but we have a responsibility too. We have a responsibility to make sure that environment experiences minimal impacts from our use. So I think we're getting there. I think that message is getting out there, and the sign that populations are recovering and ocean ecosystem is getting better is a sign that we're being better stewards of the ocean.
And speaking of ocean stewardship, I know that you and a colleague, Stephen Manley, are working on a project, just began the research, on the effects of radiation leaking from the Fukushima nuclear plant in Japan. Tell us what the parameters are of that research. I know you're looking into the kelp forest and the impact on the kelp forest, but what are the parameters of the research, and what do you hope to learn from that research?
Well, working with my colleague Steve Manley, who's an expert in kelp, you know, he was the first to really figure out that here in Southern California, after that incident, we could use kelp as an indicator, like a dosimeter, a badge that people would wear that work around radiation as a way of measuring what gets into the ocean and where does it, how does it travel through the food web. So Steve's idea was to go out and collect kelp from all different locations and see how long it took for us to see that signature in our coastal environment. And we were able to actually document that a month after the incident. It took a month for the atmosphere to carry over those radioactive materials to actually end up in our ocean. And that brings about a really interesting thing that I think we have to focus on now. Let's say we've done a really good job at cleaning up our regional ocean and fixing regional problems. But what this system indicates, this incident in Japan indicates, is that what happens across our ocean, we can actually see the effects here. Now, they may not be detrimental, but we can actually measure them. The point is, we need to start thinking more globally about what happens. We've done a good job looking locally and regionally and fixing problems that we've been able to detect. Now we need to start thinking globally, and this is a completely different game. This goes beyond just our local community and our local legislation. This means looking at things globally. The oceans are connected, and we are now able to measure events that occur across oceans. How they're going to affect all the work that we've done to bring our ocean back is going to be really important, and this is going to take a global effort.
It's going to take a lot of international cooperation on this issue, to be sure. We're almost out of time, Chris, but in just 30 seconds, tell us about seafood and fresh seafood and what the difference is these days. I know you come from a family of fishermen, in addition to being a marine biologist. What are your thoughts about seafood?
Well, you know, we're told that seafood's good for you. It's a healthy form of protein. Harvesting it in a way that's sustainable is getting much better. We import over 80% of our seafood, and we need to solve that problem, whether it be through aquaculture or better sustainable fisheries here. I've seen a lot of commercial fishermen go out of business. We've basically driven them out of business. The few that are remaining are actually making a living for the first time, and they're supplying their communities with good, fresh fish. And unfortunately, much of the public doesn't know what fresh fish tastes like anymore. So I think there are opportunities here to really do that and do it sustainably.
Thank you, Chris. We are out of time. I want to thank you for joining us today, and thank you for joining us on Talking Points. Join us again for another episode soon. Until then, I'm Dave Kelly. Have a nice day.